Hello, everyone, future innovators and game changers. How's it going? I hope your day is awesome. I hope I'm audible, first of all. Great. As I hope your day is awesome, as the session we have planned for you, a massive shout out to all of you for joining today's exclusive fortnightly session titled Unlocking Robotics and Career Possibilities. This session is specifically designed for you, the trailblazers of tomorrow from grades 9th to 12th. With the purpose to dive into the electrifying universe of robotics and the endless career path it opens up. I'm Aniket Arora, your moderator for today, and let me just say it's an absolute vibe having you all here. Your curiosity and energy are what make these sessions so impactful and, let's be honest, way more fun. Please, I can see that many of you have turned on your video. I would like to request that all of you, it would be great if you can all turn on your videos and actively participate. It's lovely seeing your faces. Thank you. Yes, you can all turn on your screens. Great, great. Please turn on your videos. So today we've got a tech genius in the house, someone who's practically a superhero in the world of cybersecurity and robotics. I would like to introduce our speaker for today, Mr. Adin V.S. Mr. Adin is no ordinary guest. He's a cybersecurity specialist and knowledge officer at ICT Academy, Kerala, with a master's degree in cybersecurity from IIITMK. With over 3 years of hands-on experience, including a stint as an IT security auditor at EY GDS, he's basically the Tony Stark of tech. And if you're not impressed by this, I'd like to mention that he's also published researcher on acoustic side of channel attacks. But don't worry, he'll explain what that is. With expertise in IoT, embedded systems, and AI robotics. Talk about tech-savvy trailblazer. Mr. Adin is all about pushing the boundaries of innovation, advancing organizational security, and making a real impact in the tech world. So let's light up the chat with some emojis and give Mr. Adin a huge virtual round of applause.
Thank
Can we
you,
have a
Aniket.
virtual
Thank
round
you
of
for
applause?
thank you for those words, and yeah, it meant a lot to me.
For anyone new to our platform, I'd first like to introduce what CAMP is all about. The Knowledge and Awareness Mapping Platform, CAMP, which is an initiative of the CSIR NISPER, dedicated to bridging the gap between education and real-life application. Our mission is to cultivate a scientific mindset among students while nurturing their hidden talents. Beyond online session, CAMP also organizes quiz competition and exciting scientific excursion to places like CSIR, ISRO, and DRDO, allowing students to explore science in real-world settings. If you're interested in these excursions, check out the link in the chat for more info or reach out via the helpline number. Now, without further delay, let's welcome Mr. Adin. Mr. Adin, the stage is all yours. And to students, I'd like to mention that your participation is very important. Please stay engaged, use the chat for comments, and feel free to raise questions during the session or after the session as Mr. Adin allows. And before we proceed, Mr. Adin, I'd like to mention that all the students are on mute. And in case if you want to interact, you can let us know. We can unmute them.
Okay, sure. I will let you know.
All right. All yours.
Okay, yes. Hey everyone, hope everyone is having a great day ahead. And yes, as Ankit mentioned, my name is Satin VS and I'm a cybersecurity specialist, and I will describe about me bit after a slide. So yeah, I know you are all enthusiastic about robotics, right? Like you want to learn what is robotics, want to know how you can get into the robotics, everything, right? So Yeah, just a minute. I'm getting a pop-up from this Zoom chat. Okay, get out. Yes, so today we will be exploring this robotics and yeah, for robotics, the hardware is required, right? But in this session, we are doing everything virtually. So yeah, of course, a hardware is required. Like I'm having a, I will like explain it in a bit later. But for robotics, you need a hardware. But for the initial investment, like what I meant by in the learning stage, you can just start it by software itself. Like there are some on so many multiple online platform. From there you can learn this robotics. So I think we can get started. So let me share my screen once. I hope this is visible. My screen is visible.
Yes, it's visible.
Okay, great. So I think without wasting any time, we can get started. The topic is the power of Arduino unlocking robotics and career possibilities. So that's our topic. So let me ask you one thing. Have you heard about this news? So this is by SpaceX. SpaceX launches a Starship rocket and catches booster in a giant metal ram. So this was a recent news that you might have heard. So for those who haven't heard it, let me play a video for you. Oh, just a minute. The music might be stopped, so I will reshare again. Okay.
4, 3, 2, 1. We have liftoff.
Vehicles pitching downrange.
One booster catch. We're going to ignite 13 of those Raptor engines, and this view is incredible right now. You can see how fast this vehicle is moving on the left-hand screen. Landing burn has been ignited. We're now down to 3 Raptor engines. We can see those chopsticks now in the air.
Yes, that's the news. The SpaceX launches Starship rocket and catches booster in a giant metal ram. So this is a no. So why do you think I'm discussing it here? So because you can see the rocket goes and it came back, and there's 2 metal lamp just like a chopstick. It picks or it catches that rocket or precisely the rocket booster. So how do you think it was possible? It made possible. So mainly, so many people works on it. To be fair, so many people worked on it. But when we are taking the list of those, it includes aerospace engineer, robotics engineers, software developers, electronic engineers, data scientists, project managers, and visionaries. And here, as we know, aerospace engineers are plays an important role in this project. But we are emphasizing here on robotic engineers because they are the one. For robotics, it involves so many things like AI, programming, and software. So many components, and we need to ensure that everything automation and everything works in a perfect sync. So here, the robotics engineers plays a critical role in building this Maxilla booster catching system. So that's why I'm mentioning the role of importance. The role of robotics is essential here. Yes, so to your question, where should you start to become a robotics engineer? So robotics engineer means designing and building robots for specific application, developing intelligent robots, so these kind of things. So ever thought where you could start to become a robotics engineer? Well, don't worry, in this session, we'll be exploring these things. So I'll be guiding how you can get into this robotics field. So I can give you the road where to start and how you should be going. And rest, I will provide like based on the roadmap, you have to move and go forward. Okay. Yes. So today in this class, we'll be learning the basics of robotics via this Arduino. So Arduino, it is a kind of a microcontroller. So this is the one I'm having. So this is like a powerhouse. You can create your own DIY projects, like do it yourself projects. Suppose that when someone enters into your room, you want to get some kind of notification or some kind of alert system like intruder detection. So suppose that you want to build something like that, or say if you want to touch on your mobile, like activate a switch, and you wanted to light everything in your home. So this kind of project you can make possible using this Arduino and related related aspects or domains. Okay, is there a certain course for? So I'm getting some direct messages. You can make it public as well, but the question is there any certain course for robotics? So of course there are so many certain course for robotics. uh, like you can like, first of all, if you want to pursue robotics, there is no need for any courses. Everything is available online, YouTube or some documentations. So I will provide how you can get started. So that part I will cover in our Q&A session. We will explain that. So here, as our topic suggests, Arduino the gateway to robotics. So robotics transforming our world, and this Arduino is like a stepping stone using which we can create this robotics project. So now choose what we'll be learning today. Everyone is like, we only have 1 hour, and what we are going to learn today, is it possible? Some of you don't have any idea of robotics, what is coding. Yeah, I understand that part, but what we'll be learning today? So before identifying or before mentioning what we will be learning today, like a disclaimer, we need to code. So in order to get into robotics, we need to code. So basic coding is essential. Without that, we can go further. Then there should be some compatibility. There's some, like, suppose that this board support 5 volt, but instead that, if you're supporting 12 volt, it will burn off. Okay, so that kind of some precautions is required. So so the no worries, we are using software, so that kind of issues is not there. So without waste time, let me mention what we are creating. I am a movie. Yes, that is a robotic arm. And today in this session, we'll be learning how we can create a robotic arm using Arduino. So that's our topic. So if you are excited, comment yes in the chat. So if you are excited on learning robotic, how you can create robotic arm using Arduino in an hour, type yes in the chat. Okay. Okay, great. I could see some yeses, and most of them are direct messages. So maybe not others could see, but so many are giving me yes. Yes. So a student has mentioned, what is the difference between AI and robotics? So AI is artificial intelligence, and robotics that involves hardware and components. And there's a field called AI robotics. So AI is like AI is intelligence. So artificially we are what we can say artificially intelligence. Artificially we are simulating human intelligence. So that field is called artificial intelligence, and robotics is mostly involving hardware and components and interacting with them. And AI robotics is the field that's the merging of AI and robotics. Okay, so robotic app, how we can create it? So before going further, let me introduce myself. So my name is Sadhan VS. I'm a cybersecurity specialist at ICT Academy of Kerala. I have been with EY for 2.5 years, and I have graduated MSc Cybersecurity from Institute of Information Technology. And apart from cybersecurity, my domain of expertise includes IoT, robotics, and embedded systems. So that's a bit about myself. So moving on. What is Arduino? You might have seen this and you might be wondering what this is. So this is Arduino. The name is Arduino. If you have searched, let me search here as well. So if you have searched Arduino, it's Arduino. You will get many results, and most of this include a board, and the board has so many holes and so many chips, transistors, these kind of details. So you might be wondering what it is. So if we search for something more Arduino project, then you could see the enormous possibilities what you can make. With the only limit is your imagination, and of course you need the hardware components, and you could create so many projects based out of this Arduino, and this Arduino projects is a stepping stone into robotics. Okay. So okay. So what is this Arduino? Arduino is an open source powerhouse. Like it is a microcontroller. Basically, this is a PC computer, more like CPU, but CPU could do so many things, but this could only do the specific thing. So that's why it is called a microcontroller instead of microprocessor. And it is designed for beginners, allowing you to control electronics with code. Okay, I'm repeating it again, controlling electronics with code. So it comes with an Arduino IDE. So Arduino IDE is like a coding platform. So this is the Arduino IDE. So here, yeah, here we are coding something. Oh, sorry, I will share my screen. Okay, so here, so this is this Arduino IDE. This is like a coding platform, and here we could code. And once we have coded this, we can upload our code into this Arduino. So that's how it is working. And finally, as I mentioned, this allows DIY projects for innovations. Like we could create prototypes. So prototypes means suppose you want to create a product of your own, but first you have to test the basic how it will be working, or whether it is feasible to develop a working product. So that kind of thing is called prototype. So this allows us to create prototypes, and it can be used for home automation and so many projects. Then, so in order to make this robotic app, what are the items required? So we need three things: servo, a potentiometer, and Arduino. So I have introduced you what is this Arduino. So next, we need a servo. So servo is something like this, like as you have seen the uh, slide. So servo contains a arm which we can twist. Okay, so that's how it is working, and there's a nice sound to it as well. I don't know if you can hear it or not. Okay, so now I'm manually testing it. So sorry, manually testing it. But instead of, there is some electronics, so with which we can control it. So suppose that I want it here, I can send signal. Suppose that I want it here, I can send signal. So that's how it is working. So servo is a combat motor used for precise control of angular momentum in robotics. So that's simple. And then comes potentiometer. So potentiometer is this one. So this contain a button. So we can twist and send. So this is more like a radio button. So this is the robotics project that I'm using. So here there is one potentiometer. So here I can twist and turn this potentiometer. So that's how it is working. And finally, we have Arduino Uno board. So these are the three components that we require. Yes, I'm getting a hand raise. Anything, Uma Maheshwar? Okay, so let me give you an overview of what we are aiming.
Today's tutorial is an extremely simple tutorial on how to control a servo using a potentiometer through your Arduino. Here are the things that you'll need for this tutorial.
I hope you have
Today's
seen
tutorial
it. So here the guy is testing his potentiometer, and this potentiometer is sending this potentiometer is sending a signal to Arduino, and the Arduino is processing, and that signal is forwarded to this servo. So that's how it is working. I'm explaining it once again. So here the man is testing his or turning his potentiometer, and that signal is going to Arduino Uno, and this Arduino Uno process these signals and transfer it to servo, and the servo arm turns. Okay, so that's how it is working, and this is our final project. So this is also a video. So here, let me see if I have any kind of laser pointers. Okay, no sure. So here, there is the potentiometer, as you can see, and each potentiometer is controlling each servo. So this potentiometer is controlling this servo, this one, this servo, this one, this one, this. So there are 4 servos for potentiometer. Everything is merged into one piece. So I'm just playing this video.
Hello, in this video.
Okay, so that's how it is working. So basically I have developed that prototype by myself. So as you can see, so this is the prototype that I have developed. So basically I have 3D printed these parts and added those servos into that. And instead of potentiometer, I'm using some serial monitor kind of thing. So ignore that part. But here I have inserted 4 hot rows. So one servo is here. This is the second servo. This is the third servo. And here comes the 4th servo. So 4th servo I have attached to this claw. So you might be thinking how this claw working. So basically by turning a potentiometer, we are moving a servo. Okay. So you might be wondering, we are just turning a servo and how this robot arm works. Okay. So for that answer, here also you could see there's a servo, and this servo is attached to this white arm. So just like this arm, this is the servo moving. So when the servo moves using the gears, the other hand moves. So that's how just by turning this servo, we could move this part. So when this part is moving, the next arm automatically moves, and thereby we are getting a robotic arm. So that's how it is working. So that's why we have aimed. Our project include 4 stages. First, using a potentiometer, we are turning a servo, and then next step, using 4 potentiometer, we are turning 4 servos, and that is our robotic project. Okay. So yeah, this is the robotic project that I have created. So just a small demo. So what you are expecting? So yes. Okay, basically, so this is what we are aiming. So now, without wasting any time, we can get started and learn how we can create this project from scratch. So of course, the first step is coding. So I will try my best to make it as simple as possible. Okay, so this is the code. Okay, I have received a chat. Sir, can I ask a question directly by talking? Ankit, could you please unmute? Like a student want to talk.
Sorry, can you please repeat the name?
Uma Maheshwar.
Oh, she's on mute.
Like she have sent me a direct message. She want to talk something.
Hello, sir.
Yes.
Can you hear me?
Yes. Audible.
I have a small doubt. So
Okay.
can we program anything into a chip that's created already, or should we program it before it's fully done?
So basically, everything we have to program from scratch. So there is nothing like pre-programmed robotic. Everything we have to start from scratch. Okay, did I answer the question?
Okay, sir.
Okay, yes. I will show you how that. So first of all, when you get into this site, this software, so this is Arduino IDE. If you search for Arduino IDE, this is the place from where you could download this software. So if you are using Windows, you could install or download this software and open it. So when you are opening it, you will get something like,
Okay.
yeah, something like this. So this is our playground. Okay, and here we have to write our code. So I have written the code. So this is the code I have written, and I will explain what it means. So for most of the people, the coding is difficult, so it takes some time. Like in an hour we can learn it, so that's why I'm explaining it. Like as I have mentioned, I will make it as simple as possible. So first I have mentioned I'm using, this is like a library header, and identify, like assume that this is like servo. I'm using servo. Okay, and I'm naming my servo. My servo, that's the name of, sorry, yes, this servo. I'm naming this servo as my servo. Okay, so here I'm initializing my servo, and I'm adding this. Okay, ignore this part. I will explain that. And here in the setup, I'm mentioning I want to attach this servo to 9. So basically this Arduino board contains so many letters written on it, 1 to 9 and A0 to A5. So this kind of letters is written on it. Let me take an image.
Sir, another
Yeah.
doubt.
Okay.
What actually can we is robotics is like making robot stuff, right?
Yes, exactly. Yes.
So then that means can it like film something visually, like zoom in for like microsurgery type of stuff, like in the future?
Okay. Yes, that's advanced kind of project, and that involves artificial intelligence and software coordination. But yes, you can do that. Okay.
Thank you.
Yes. So this is how an Arduino, and it contains so many letters written on it. So here you can see 1, 2, 3, 4, 5, 6, and here comes the 9 part. And similarly, also here you can see analog. So this here, the right side, you can see digital pins, and the left side you can see analog pins. So the difference is analog digital process 1s and 0. Either it is on or off. But in case of analog, it varies. So suppose that if I'm turning on a bulb, so it is on or off. So that's how it is working. But suppose that I'm connecting this bulb to analog, so this bulb signal to analog, then I can increase the brightness slowly and make it full bright. And similarly, I can decrease the brightness and make it and turn it off. Okay. But in case of if I connect this bulb to digital pin, I could just on and off it. Okay, that's how it is working. And here there are some tilde symbol. Okay. So here tilde symbol means this digital could also act as analog. Okay, so that's the difference between digital and analog. And here Arduino, you could see here, okay, it is not written here. This digital pins could take input, like this digital pins could take input signals, and at the same it could provide output signals. Okay, here this analog pins, it could only take analog inputs. Okay, so that's just basic, not getting into much details. Okay, so here my servo has been attached to 9. So that's how I have attached it. And here like my this potentiometer, so this one servo I have attached to 9, and this analog pin I have attached to A0. Okay, I could even type here A0. Okay, so I'm explaining once more. Here I have attached my servo to 9, and here I have attached my potentiometer to A0 pin. Now, like I have attached my potentiometer to A0 and my servo to 9th pin. And finally, I'm doing some kind of code here. So basically, this code means I'm taking the input from potentiometer and transferring it to our servo. So that's how it is working. So that's a simple code here. Now we can get hands-on. So if you have a system, you could also try it parallelly. So I'm opening a website called Wowkey and selecting Arduino. So here it is. So here I have the Arduino. Now I want what I have mentioned. I want a servo and a potentiometer. So I'm just adding that. I'm adding the servo and adding a potentiometer. Okay, so I have added it here. So as you can see in the servo, there are 3 signals. There's a ground, there's a positive or VCC, and there's a signal. So ground means, so if you are connecting a bulb to a battery have a positive and battery has a negative. So similarly, I'm connecting this ground to here. So here you can see there's a ground attached here, and similarly this positive I'm connecting it to this 5 volt. So basically, imagine this Arduino is a battery. Okay, imagine just this is not a battery, this is a microcontroller, but it could power things. So here you can see there's a 5 volt. So I'm supplying 5 volt current to this servo, and here the negative is connected to GND. So as you can see, there are multiple GND here as well. So you could also connect this GND to here as well. Okay, and similarly, I'm connecting this GND to here, and here also, as you can see, there is a VCC here. So VCC means positive. I'm also connecting this VCC to 5 volt again. Okay, now I'm going back to our code, previous code. Okay. This is our code. I'm just copying it and pasting it here. So this is our code. Okay, so this is our code. So here, as I have mentioned, I'm attaching this servo, my servo to 9. So same process I'm doing. So this is a signal. So it says PWM. So that is technically simulating analog signals. So that's what PWM is. I'm not overcomplicating things. Just assume that, just understand that this is a signal. So I'm connecting this signal to 9. And similarly, it says this wall is like I'm connecting this potentiometer to A0. So similarly, I'm connecting this signal to A0. So this is how we have completed it. Now I'm going to play it here. I will get error. So install servo library. So don't worry, just press enter. Like the library has been installed, and I'm playing it again. Okay, so you could see I could turn, like when I'm turning this potentiometer, the servo is moving. Okay. Okay, so basically, when I'm turning this potentiometer, this servo will be turning. So that's kind of automation we have done using, we have completed or we have created using this Arduino. So here, this is the code that made possible. So the potentiometer provides the value from 0 to 1023. So this is the range of potentiometer. So if you are turning it down here, this means zero brightness of LED. And if you are maximizing it, maximum brightness of LED. And if you are making it into half percentage of brightness in the LED. So that's how the signal goes. And this signal is converted to servo signals. So servo, we are asking the servo to 10 degree, 20 degree, 90 degree, and finally 180 degree. So that's how this servo could turn 180 degrees. Okay. So this is a simple code and we have made it possible. Now we are going to much more larger version. So I have created that code already. Okay. Yes. So this is the code that I have developed. So basically everything is same. So here I have 4 servos, 1, 2, 3, 4, 4 servos, and each one is connected to, okay. So before that I should introduce you to what is this LED, this breadboard. Okay, my mistake. So let me go back and introduce you what is this breadboard. So, sir, is it possible to get in contact with you after meeting? Yes, I will provide my contact details in the end of the video. Sorry, end of the session. Okay. So here we have a breadboard. So full half. So I'm going with half. So this is the breadboard. So it is more like, so as I have mentioned, assume this Arduino board as a battery. So assuming it as a battery, I'm taking a positive to here and this negative to here. I have just connected it here. Now the thing is, the breadboard is most like a connection, multiple connections. So if I'm adding a LED here, okay, I'm adding a LED here, and from here I'm connecting it here, and from here I'm connecting it here. I will explain what I have did. Okay, so basically I have connected an LED to a battery. Okay, so here from the battery, so this is, I'm repeating it again, this is not a battery, this is a microcontroller, but for the understanding purpose, we are assuming it as a battery. So here, this 5 volt goes here, okay, and this whole line is connected. This whole line is connected. This whole line is connected. So and similarly, this whole line is connected as well. So and here similarly here this will connected. So this how this breadboard works. So everything is connected. So similarly, this also connected. So I'm just removing this one. Okay, so now I'm turning on. So see this LED lights. So basically the current goes to 5 volt and it enters here and then it transfers through here and the LED lights. And here this negative goes here to this hole and this everything is hunted here. And finally it exits through this wire and finally it reaches ground. So that's how this LED is getting lighted. So suppose that I'm removing this LED and instead of this hole, I'm choosing this hole. So, okay, now I'm playing it. See, it still works. So basically this is more like connection, nothing else. So breadboard is not complicated, but just a connections. So in this one that I have created, I have used a breadboard and here I have provided positive. Sorry. Yes. So here I have provided positive and here I have provided negative. Similarly, breadboard, here I have provided positive, here I have provided negative. And from each potentiometer, the ground has been connected here and the positive has been connected here. And similarly, from each servo, the ground has been connected here. The ground has been connected and similarly positive here as well. So that's how I have done. Okay, let me see. Okay, so I have connected that, and here, as you can see, here I have connected 4 servos. Servo yellow to 9, brown to 10, green to 11, and fourth servo blue to 12. And similarly, I have 4 potentiometer. So here I have connected my potentiometer 1 to A0, 2 to A1, green to A2, and fourth potentiometer blue one with to A3. So basically, so here I could control this each servo using each potentiometer. So basically this is the same. We have created our program using one servo, but instead of using one servo and one potentiometer, we have expanded our project to 4 servos and 4 potentiometer. Okay, so basically that's it. And this project, so this code may seem a lot, but basically simple. Like I'm just naming this server 1, server 2, server 3, server 4. I'm connecting my pin to like potentiometer to A1, A2, A0. So these kind of simple details I have programmed it. So if you are difficult in programming these things, don't worry, ask ChatGPT. So mention what you want to tell, like what you want to build, and ask ChatGPT to create a Arduino code program for you. And ChatGPT could build this. So in order to create this one, your prompt should be, I have 4 servos and 4 potentiometer and a Arduino Uno. How can I code or create a Arduino code for me? Then ChatGPT will create the code for you. Okay, so that is simple. So actually, this is our robotic. Okay, trust me, this is our robotic app. So this robotic app that I have created have 4 servos and it is connected to some external connects, but it also have 4 potentiometers. And when I twist this potentiometer, this servo moves. And if I'm okay, so suppose that I'm having 4 servos. So suppose that I'm turn the first potentiometer, then this one turns. Okay. Then second potentiometer, then this one turns. Okay. Then I'm turning the third potentiometer, then this one turns. Okay. And finally, I have the fourth potentiometer. And when I move that, this robotic arm claw that changes. Okay. Okay. Now I will show you a video how that is exactly happening. How the servo is connected to this 3D printed parts. Okay. So this is the one. So here this is a 3D printed part and it contains a servo attached. So 3D printing is some kind of a robotics basics. Designing 3D items and printing 3D, that is a part of robotics as well. So I will fast forward this one. So basically some components, and this is a servo. So yes, so they are just assembling things. Okay, so this is how this robotics part after the 3D printer parts after assembly looks like. So here, yeah, so here there's a servo and it is attached to this one. So when this one turns, the next one automatically turns. So that's the same process that is applicable here as well. So here there's a servo and we have from this Arduino. So from this is also a kind of Arduino. So Arduino is of almost 50 types. So this is a small one and this Arduino is a large one. Okay, so from this Arduino, it is connected to a servo and the servo arm. So this servo arm is connected to this white arm. So this, as you can see, this white arm contains a screw in it. So it is just tightened. So when I'm changing this, okay, so when I'm changing this arm, the other arm automatically moves. Okay. So that's how we made this gripper possible, like claw possible. So that's how it works. And now to a Q&A session before going further. So you might have so many doubts, I know, because it is not possible to complete or understand this coding and robotics, everything in an hour. So question round. You can use the chat and ask questions. And I will try my best to make it or address your questions as simple as possible.
Or they can raise their hands virtually and we can pick them up one by one.
Okay. So in the Zoom, I hope this is visible. So here in the React session, you could see there's a recognize hand gesture. Sorry. Okay. Okay. Click on the React button, and here you can see raise your hands. That's how you could raise your hands virtually.
Right. So students, if you have any question or any doubt, you can go to the React option. There's a heart down there and it's written React. So by selecting on it, you can select on recognize hand gestures.
Okay, I guess many are playing with that React buttons. Okay. No issues, no issues. Like if you have any doubts, if you are afraid to talk, no issues. You could use the chat window and you could type
Yes.
that there. And yes, okay. Okay, anyway, I hope you are not having any doubt. Anyway, I will sum up what we, okay. Aman is having a doubt. Yes, Aman. Okay, we'll unmute in a minute.
Aman, can you please unmute yourself? Yes.
Yes, sir, I have a doubt, but my doubt is a bit out of the topic.
No issues, no issues.
So my doubt is related to the ultrasonic sensor. Basically, the ultrasonic sensor has a very big limitation, that is its distance.
Okay, yes.
Right? It covers a very small distance. Oh, and it does
Yes.
not recognize the object perfectly. So is there any way that we can overcome that limitation to improve the robot?
Okay. Basically, okay. Sometimes this ultrasonic sensor works unacceptably and we are not accurately getting the data. So sometimes you have to adjust this response times in that. Okay, like instead of going for fixed hold, basically the trigger activates and the sound waves goes and the echo pin is getting it back. So that way there's a delay in between. So try to adjust that delay and sometimes you will get the accurate results. Okay. Yes, in the chat. Is single-handed programming possible? Is single-handed programming possible? You mean like you yourself have to do everything? Like it is possible. Like group work and single. I hope that you meant. I'm not clearly understood that. But yes, it is possible. Okay. Then in that case, let me resume the slides. Okay. Finally, to the career opportunities robotics. So robotics have various opportunities. So basically, as I mentioned the basic video, you could create and the job opportunity is enormous. And also you could see an automated self-driving cars, drones, so that kind of autonomous systems, healthcare industries, surgical robots, smart manufacturers, automations, and space missions, home assistants, automated farming. So this in not only this but so many other fields. So there is a wide career opportunity in robotics. And talking about the future, so as of now, the robotics is redefining the future, like the revolutioning introduce industries and powering by innovations, and many people are getting into AI. So I hope you have seen the Tesla robot. So if you haven't, just search it, Tesla robot. So this is a new Tesla robot. It is named Optimus, and it could see so many robotic things using artificial intelligence and many other sophisticated functionalities. Yes, so that kind of enormous possibilities is still in the robotics field, and the future of robotics also seemed very much what we can say innovative and innovative, I could say, and futuristic as well. So this is how everything is. So you just need a hardware, Arduino. So if you want to hands-on experience, so if you want to know how to get into this, so I will suggest this site Woki. So here you just need to learn coding. So that's it. So here you have done the code, and instead of buying a hardware part, so at the initial times there's a high probability that you might supply high voltage into this Arduino and it will get burned out. So in order to mitigate that, or in order to solve that issue, mostly financial issues, you could use this simulation software and you could try everything from this website itself. So the question is how you can learn this Arduino coding. So just Google it, Arduino tutorials point, and they have provided a good guide. So what is this Arduino overview? What is a board? How it works? Each and every component, what it means, and what are the coding language to be used? How we can utilize the operators, control loops. So there are so many things and the base you could get in a 1 week or two. So you could get the base. So it is easy. So don't worry by seeing these random words and characters. It is easy. So basically using this guide, it is available online and it is completely free. So this way you can learn Arduino programming. So once you have learned this Arduino programming, you could test your project code and everything on this platform, this online platform, Wolfkey simulator. So here you could get the components and everything, connect it, try it, nothing could go wrong. Okay. And once that is done, your third phase is buy a Arduino kit. So in the Amazon, you could see there are so many Arduino kits available online. So it comes with a cost, and there are some under 500 rupees as well. So this is a kit and includes so many components. So identify what are the components that you require and then purchase that, or else you can purchase a kit and you can try it yourself. So that's the first stepping stone. And then search for Arduino projects. Google online Arduino projects. You will get so many project ideas. Then try to replicate this using these Arduino jumper cables and other things. Try it out yourself, explore it yourselves. And once that is done, your first stage will be completed. Then comes the AI part, integrating AI into robotics. So that's the next part. That time, okay, so search online. Okay, everything. How we can integrate AI with robotics? So every details is provided online and it is open source. Like it could available online. You don't need to purchase a course and study all this thing. Everything is available online. So that's the roadmap, and you can get going. Okay. In case of any doubts, first talk with ChatGPT. Basic, simple doubt clarification. This ChatGPT could do. Okay, so that's it. And finally, okay, I hope you are not having any questions. In case, feel free to ask your questions, and as I mentioned, I will try my best to answer it. And if you don't have any questions, so this is the conclusion of our session. And yeah, that's my email.
We can take one more question from Aviral X. Aviral, can you unmute yourself and ask your question?
Sir, it is not directly related to robotics, but could you please guide on how to pursue VR or AI fields?
Pursue VR or AI?
AR,
augmented reality or virtual reality.
Okay, yes. Okay, AR and VR. Okay. So AR and VR, so this Coursera is a good site, and so many courses is provided by Google. So you could see certified courses provided by Google. So first search on Google Coursera, or similarly go for Udemy courses. So Udemy courses, you could find Udemy courses. Let me search it for you. Okay, there are so many AR VR courses available. So basically, I haven't got into AR VR myself, so I couldn't provide more guide into that. But these are the experts. So choose one person, refer the reviews of the student, and if you like the review, and also if you are suppose that I'm getting into this one, and I could see the table of content. So what you will learn. So these are the things that you will be learning by taking this course. So understand that if this content aligns with your goal, then go for it, and also check the ratings. So that's how you could select a good course and thereby get into the AR VR domain.
Thank you so much, Mr. Adin, for such an inspiring and informative session. I'm sure that our audience now has much clear understanding of the topic today. And once again, thank you to the audience for such enthusiasm and participation. And a big thank you to Mr. Adin for sharing his wisdom and experiences with all of us today. Thank you so much. And we hope to collaborate similarly again in the future with you and your team. Thank you so much.
Yes. Thank you, Angit. Thank you, students. Your participation means a lot to me. Thank you.
Thank you. So I have a message for all the students that the recording of this session will be available on your Camp NASTA login panel. And for any further support, feel free to reach out via our website, www.kamp.org.in, or our helpline number, or the social media links that I have shared in the chat below. And before we conclude, we request you all to take a moment to fill out a quick survey form. Your feedback helps us improve and serve you better. So please take out a few minutes and quickly fill out this survey form that I'm sharing in the chat below. Thank you everyone for being a part of today's workshop. Stay tuned for our next exciting camp session. Until then, keep exploring, learning, and applying these strategies in your life. Have a fantastic day, everyone, and we'll see you in the next session. Thank you.